let's go ahead and get started. Numbers 29 through 36, the directions say to evaluate the trig function of the quadrant angle if possible. Now remember, a quadrant angle is an angle that in which the terminal side lands right on one of the axes, okay? So 90 degrees is a quadrant angle, 180 is a quadrant angle, 270 is a quadrant angle, 360 is a quadrant angle, 450, go around once plus 90 more, 450 is a quadrant angle, okay? So all of these angles are quadrant angles. In this class, we are going to use our calculators to find quadrant angles. I'm not going to make you memorize. Some teachers do, I don't. I'm not going to make you memorize the quadrant angle trig functions, okay? So, here we go. Cosine of pi, that's the same thing as 180 degrees. If your calculator is in radians, use pi. If it's in degrees, use 180. So the cosine of pi or 180 is negative 1. So there's your answer, very simply. Negative 1, easy enough. Cosine of 3 pi over 2. Now if you convert 3 pi over 2 to degrees, you'll get 270. You should know how to do that, okay? So you should know whether or not your calculator is in degrees or radians, okay? Mine is in degrees, so I'm going to type in cosine of 270 and get out 0. So the cosine of 270 is 0. Alright, moving on to number 31. Secant of pi. Well, pi is 180 degrees, and we do not have a secant button on our calculator. However, the inverse of secant is cosine, so I'm going to find the cosine of 180 degrees, or the cosine of pi. So the cosine of 180 is negative 1. So the cosine of 180 is negative 1, which we knew that already from this right here, okay? Now, remember, secant and cosines are inverses of each other. So, if the cosine of 180 is negative 1, you then take this answer and flip it. And that will give the answer to the secant of 180. Well, negative 1 is the same thing as negative 1 over what? 1. If you flip that, you get 1 over negative 1. And 1 over negative 1 is the same thing as negative 1. So in other words, when you take negative 1 and flip it and find the inverse, you get negative 1 also. So the answer is negative 1. Alright? Okay, number 32. We're going to find the secant of 3 pi over 2, which is 270 degrees. Now, we do not know the, we do not have a secant button on our calculator, but we do know the inverse of secant is cosine. So instead of finding the secant of 270, I'm going to find the cosine of 270, and then go from there. Well, right here's the cosine of 270. We already found that, number 30. The answer is 0. Now, I want to teach you a shortcut here. When you're dealing with trig values of quadrant angles, trig functions of quadrant angles, anytime you're looking for the inverse of 0, you'll get undefined. And anytime you're looking for the inverse of undefined, you'll get 0. So in other words, undefined and 0 are inverses of each other when you're dealing with quadrant angles and trig functions. So, having said that, I'm trying to find the secant of 270, but there's no secant button, so I find cosine of 270, which is 0, then find the inverse of 0, which is undefined or no solution. Undefined or no solution, okay? Alright, tangent of pi over 2, or in other words, tangent of 90 degrees. Well, if you type that into your calculator, you're going to get error or mistake. So that means this is undefined or no solution, okay? Undefined or no solution, okay? Alright, tangent of pi. Okay, type in tangent and then 180 degrees, or pi, depending on what mode you're in, and you're going to get out 0. So the tangent of pi is 0. Now let's find the cotangent of pi over 2, or the cotangent of 90 degrees, same thing, alright? Well, there is no cotangent button, but the inverse of cotangent is tangent. So I'm going to find the tangent of 90. Well, I did that right here. So the tangent of 90 is no solution or undefined. students had a son there that was yelling. Okay, here we go. So let's go back to this. Cotangent of 90. Cotangent's not in my calculator, so I'm going to use tangent. So the tangent of 90 is no solution or undefined. So the inverse of no solution or the inverse of undefined when dealing with trig functions is 0. Remember, we talked about that. 0 and undefined are inverses of each other. Okay, cosecant of pi, well, that's the same thing as cosecant of 180, alright? Cosecant is not on your calculator, so the inverse function of cosecant is sine. So instead of finding the cosecant of 180, I'm going to find the sine of 180, okay? So the sine of 180 is 0. So if the sine of 180 is 0, take the inverse of 0, which is undefined, and the cosecant of 180 is undefined. Really pretty simple, okay? Alright, here we go. Now, on numbers 37 through 48, looks like half of them are in radians and half of them are in degrees. So I'm going to do the first half in degrees, or in radians, and the second half in degrees. And by the way, if you want to do them all in degrees, like convert this over to degrees, which would be 120, then find your answer, which will be 60, and then convert it back to radians, which is pi over 3. I have no problem with that. But for me, when I teach this video, when I go for homework, I really want you guys to get used to radians. So the first 6 problems, I'm going to do everything in radians, and the last 6, I'll do everything in degrees, okay? So here we go. The directions say to find the reference angle and then sketch it, and then sketch the 2 angles in standard position. I'm going to do it all at once. I'm actually going to draw the sketch first. Excuse me for yawning, sorry. I'm going to do the sketch first and then find the reference angle. Okay, my angle is 2 pi over 3. Now from here to here is 1 whole pi. 1 pi, okay? I'm going to 2/3. So I'm going to stop before I get there. So I'm just estimating. There we go, 2/3. Alright. So this is theta equals 2 pi over 3. Now my reference angle is always the angle formed by the x-axis and the terminal side. So that angle right there, we're going to call that theta prime, the reference angle. Well, if I went from here to here's 2/3 of a pi, then I'm left over with here 1/3 of a pi. Or in other words, 1/3 of a pi is the same thing as pi over 3. So from here to here is 2 pi over 3. From here to here, this reference angle is pi over 3. So the answer is pi over 3. Alright, number 38. Number 38. Now 7 pi over 4 is the same thing as 1 3/4 pi. Okay? So from here to here is 1 whole pi. Continuing here is 1.5 pi. Remember, guys, look at it like this. Every time you move 90 is a half a pi. So there's a half. Here's another half. Here's another half. That's 1.5. Now we want to go, we've gone 1.5. And I'm trying to get to 1 3/4. So I have to go a fourth. So a fourth would be right in the middle, right here. Okay? So that's my angle. My reference angle would be the angle formed with the terminal side and the x-axis. Always draw your reference angle with the x-axis as one of the sides, not the y-axis, okay? So we know if I go here all the way around, that's 2 pi. But I didn't go 2 pi, I went 1 3/4, which leaves me with a fourth left over in here. So pi over 4, or 1/4 pi. Pi over 4 would be your reference angle, okay? Pi over 4. Alright, number 39. 5 pi over 6. Now remember, 1 movement from here to here, that's 1 whole pi. I didn't go quite 1 pi, I went 5/6. So I went here to here. Now that's 5/6 of a pi. Okay, that angle right there is 5 pi over 6. Okay, now the reference angle, of course, is going to be formed by the x-axis and the terminal side. Okay, so if from here to here is 5/6 of a pi, then in here I'm left over with 1/6 of a pi, or in other words, pi over 6. Pi over 6. So the reference angle would be pi over 6. Alright, number You can write this as an improper or as a mixed number. So 9/4 is the same thing as 2 and 1/4. 4 goes to the 9 2 times the 1 left over, so 2 and 1/4 pi. So I'm rotating around 2 pi, then a fourth more. I go around 2 pi, then a fourth more. Okay. So there's my angle. So the reference angle is going to be the terminal side with the x-axis. So it's really easy. You're left over with 1/4 or pi over 4. I mean, think about it. You rotate it from here to here is 2 pi. You want 2 1/4, so you go a little bit here extra, which is 1/4. So this little extra angle right here is 1/4 pi or pi over 4. Alright, number 42. Negative 2 pi over 3. Okay, well now we're going backwards, which is good practice, okay? So, negative 2 pi over 3, rotate that around. That would be a complete negative 1 pi. We went 2/3, so we're going to stop about right there. And there's negative 2/3. Now remember, from here to here is 1 complete pi, okay? I stopped at 2/3, so my reference angle, of course, is the x-axis and the terminal side of my original angle. So, from here to here is 2/3 pi, or 2 pi over 3. So in here I'm left with 1/3 pi, or in other words, pi over 3. Alright, so the reference angle would be pi over 3. Now, Mr. Earhart, would it be negative? No. Even though this was, no. Reference angles are never negative, okay? We don't care about the sign when it comes to reference angles. That is not important. Alright, number 42. Alright, negative 5/6 of a pi. Okay, we're going to rotate 5/6 negative, so this direction will stop right here before we get to a full pi. So there's your angle. Now, here's your x-axis. Here's your terminal side, right there. So if I went 5/6 of a pi to get me 1 whole pi, it should be 1/6 of a pi, or in other words, pi over 6. Again, the sign, negative or positive, does not matter. Okay? Does not matter. Alright, number 43. We're going to rotate 120 degrees. There we go. Draw your line. So if from here to here is 180, then what's this little angle right in here going to be? How much would that be? This is 120 right here. So this angle here would have to be 60 to give us a total of 180. So the reference angle is 60. Number 44, 135. Okay, we start here. We go 90 plus 45 more. There we go. So that would be 135 degrees. Okay. Now, the reference angle is always the x-axis and the terminal side, that angle, the acute angle that's formed. So if this is from here to here 135, then from here to here it must be 45 degrees, because 35 plus 45 is 180. Alright, moving on to number 45. Positive 225. Well, think about it. From here to here is 180. So how much more would I have to go to get to 225? 45 more. So I went 180 plus 45 more. Now the reference angle is the angle here that connects the x-axis and the terminal side. So I went 180 plus 45 more to give me 225. So this angle right here must be 45 degrees. So the reference angle is 45 degrees. Number 46, 330. Alright, we rotate 330. That's 30 degrees short of 360. If I would have gone all the way to the end, that'd be 360. But I stopped short to here. So I rotated 330. My terminal, my reference angle is formed by the x-axis and the terminal side. So if I rotate 330, then 30 more degrees would give me 360. So the answer inside of this, the answer to this smaller angle here, the reference angle, would be 30 degrees. Alright, number 47. Negative 135. Well, first of all, I'm going to go I have to go from here to here to give me 180? Well, that's going to be easy. 45 degrees. So the reference angle for 47 is 45 degrees. Remember, we talked about this a couple minutes ago. With reference angles, it doesn't matter if they're positive or negative. That's not the issue. The issue is what is the actual reference angle? Whether it's, the sign doesn't matter. Okay, I just need to know the reference angle. All right, number 48, negative 240. So I'm going to go negative 180 plus 60 more is 240. All right. So I went from here to here's 90, here to here's 90. That's 180 plus 60 more gives me 240. Now, look, the angle I'm looking for, students, is the x-axis that's going to form an angle with the terminal side. So this angle right here is the one you want. So think about it. If from here to here is 240, okay? And we know from here to here is 180, okay? Then how much more do I have to go from 180 to 240? Well, it's going to be 60 more degrees. So from here to here is 180 plus 60 more would give you 240. So the reference angle is 60 degrees. Okay, guys, I hope this homework video has been a help to you. If you have any questions, don't hesitate